This tutorial will help you to complete the questions on homework sheet number 6. The first question asks you to determine which quadrant each point lies in. So when you're looking at the x and y axis, you know that movement to the right horizontally is positive, and movement to the left horizontally is negative. In addition, the y-axis, which is vertical, up is positive and down is negative. So even though there aren't any number line marks here, I can move in the direction of these numbers by following the x and then the y number line placement. So if I'm the x, I should move to -7, I would be going left, somewhere over here. And then if I were to move -2 on the y-axis, I would be going down, somewhere over here. So that puts me right down there. Now let's review those 4 sections of the quadrant again. This is 1, this is 2, this is 3, and the last one is 4. The quadrants go counterclockwise, sort of like making a Q for quadrant. So typically when you draw a Q, you go around to the left. So again, if I have my 4 quadrants, and we use Roman numerals to identify each, a movement towards -7 and -2 would be in quadrant number 3. For question number 2, +1 is right and +4 is up, so that would put me in quadrant number 1. Now, even though I have decimal numbers over here, or really high numbers, remember it's all about the direction in which you're moving, not exactly how far you're moving. So 51.7 is positive on the x, and then -532 is down on the y. So that puts me in quadrant 4. And then the last one, which has fractions, again remember, the numbers don't matter, it's the direction. +1/8, -2/3, also quadrant 4. Alright, let's take a look at the second set. This one asks you to define, using these 3 word choices, which rigid motion would map the original gray shape to the second image, the white shape. So it looks like this circle starts on the right side and remains on the right side. So the only way that can happen is through a translation or a slide. In this one, the circle is on the right and now it's on the bottom. So that is a rotation or a turn. Rotation, and it looks to be 90 degrees clockwise. Now this one, it went from the right to the left, so that's a reflection. The second section is, again, you're going to be graphing coordinates and labeling it with the appropriate letter. So I'm going to move -4 on the x-axis and then -2 on the y-axis. So -4, -2 would be here. Label it with an A. Go back to the origin. 5 on the x-axis, +3 on the y-axis. That would be B. Back to the origin. 6 on the x-axis and -4 on the y-axis. That would be C. D is 0, 5. So be careful here. Remember, 0 on the x and 5 on the y. So 0 left and right and 5 up and down. Back to the origin. -3, then 0. And then the last one there is 2, and that's a cursor in there, 4.5. So 2 on the x-axis, and 1, 2, 3, 4.5. So I'm going to be in between the grid lines there for letter F. Turn the paper over. And let's review some of our transformation rules. You may need to look them up in your notebooks. You'll notice I always use the same coordinate here, but all of my transformations are different. So let's see. We're going to translate the coordinate A, which is -6, 9, after a reflection in the y-axis. So reflection is always an opposite, and you always do the opposite of whatever axis you're reflecting over. So if we reflect over the y-axis, we change the sign of x. If we reflect over the y-axis, we change the sign of x. Number 14, reflection over the x-axis. Well, if I reflect over the x-axis, I change the sign of y. All right, a 90-degree rotation counterclockwise, a 90-degree counterclockwise rotation. Well, we learned with 90-degree rotations that the x and y axis swap places. So I'm going to move this 9 to be the x and -6 to be the y. And then I taught you that trick where if you draw an arrow in the direction of the rotation, counterclockwise, you'll know which number to change the sign of. So that's your final answer, -9, -6. And when you dilate, you multiply. So I'm going to multiply both of those numbers by 4, giving me -24 and +36. Now question number 17 says triangle ABC is reflected over the y-axis to create a new triangle RST. So triangle ABC is reflected over the y-axis to create triangle RST. Which angles are congruent? Well, a reflection is a rigid motion, so we know that all sides and all angles are the same. Since letter A is first in the series, then it's going to correspond with the first letter in this series. So angle A is congruent. That's how we write it in math. Angle A is congruent to angle R. Angle B is congruent to angle S. And angle C is congruent to angle T. And that's how you write it. Number 18. Quadrilateral ABCD is dilated by a factor of 1/3 and then reflected over the x-axis. So that's called a sequence of transformations when you have more than one. Is the new image congruent to the original image? How do you know? Well, what happened? Two things, a dilation and a reflection. So to be congruent means you have to be the same size and the same shape. Same size, same shape. Do both of these transformations preserve that? Do both of these transformations keep you the same size and the same shape? This one does, but this one does not. So when it asks me if my new image is congruent to the original image, I say no. Because a dilation is not a rigid motion. It changes the side lengths, or it changes the measure of the side lengths. Let's take a look at the last question. Triangle A and triangle B are graphed on the coordinate plane below. Which sequence of transformations, remember a sequence is more than one, which sequence of transformations will map triangle A onto its congruent image triangle B? So triangle A is this red image, and we want to get it over here to triangle B, which is this blue image. So let's take a look. A reflection over the x-axis, and then a reflection over the y-axis. So a reflection is when you are equidistant to your line of symmetry. So here's my line of symmetry. So if I reflect A over the x-axis, instead of being 2 up, I will be 2 down. So that puts it here. 1, 2, 3, 4. 1, 2, 3, 4. So this would be A after a reflection over the x-axis. Now if I then reflect over the y-axis, I don't even have to draw it. I know that the triangle will be facing that way, so that one's out. How about a translation 8 units down? So if I translate this 8 units down, 1, 2, 3, 4, 5, 6, 7, 8, and then I reflect it over the y-axis, again, it would be facing that way. So that one's out. A reflection over the x-axis, then a translation 6 units left. All right, let's see. So the reflection, 1, 2, 3, 4, a reflection over the x-axis would put me here. Oops. Reflection over the x-axis would put me here. And then if I moved it, let's see, 6 units left. 1, 2, 3, 4, 5, 6. That's the winner. All right. That is it. That concludes the tutorial for homework number 6. Good luck.